Welcome back, mathematicians. In this video, we are going to do more examples where we are working with function notation. In this example, we are given the function f of x is equal to the expression x plus 5 divided by the expression 2x minus 1. We're starting by finding f of negative x. And when we do this, we are taking out the input variable x and we are replacing it with this expression, which is negative x. Anytime we do this substitution, it is recommended we use parentheses for that substitution. So now it's 2 times, and I'm going to fill in the blank here in a moment, and then minus 1. In that blank should go the new expression, which in this case is negative x. From here, I must simplify the numerator and denominator. So in the numerator, I just have negative x plus 5. In the denominator, I'm going to multiply the 2 and the negative x to get negative 2x minus 1. Now this might be an acceptable answer, however, you might be required to take this a step further. And to take this a step further, we would factor out a negative from both the numerator and denominator. So we would have negative times the quantity x minus 5, and we would have negative times the quantity 2x plus 1. We can now reduce the numerator and denominator by that negative 1, resulting in our final answer of x minus 5 over 2x plus 1. Now let's go to the second example where we are asked to find negative f of x. Now negative f of x really means negative 1 times the function f of x. So again, I'm going to replace the function notation f of x with the equation that it's equal to, which is x plus 5 over 2x minus 1. Now from here I'm going to multiply. Now one thing I want to highly suggest here is to maybe change this into negative 1 over 1, because when we multiply fractions we're multiplying across. What I see unfortunately is that people will multiply the negative 1 to the expression in the numerator and the denominator. In reality it should just be the numerator or the denominator that gets multiplied to negative 1. In this case I'm choosing the numerator, so now I get an answer of negative x minus 5 over 2x minus 1. So that is the expression that negative f of x is equal to. Now I am given f of x minus 3. So like the first one, I have a new input expression. Instead of x, it's x minus 3. So just like the first one, I'm going to take out the x variable using parentheses where the x variable used to be, and in its place, I'm going to substitute the x minus 3 for the x. So now I have x minus 3 in the parentheses. And from here, I'm going to go ahead and simplify the numerator and denominator. So notice I have some like terms in the numerator, negative 3 and positive 5. Those simplify to be positive 2. So now I have x plus 2 in the numerator. In the denominator, however, I'm going to distribute that coefficient of 2 to everything inside the parentheses. So I get 2x minus 6 and then minus 1. Simplifying again, I see I have like terms in the denominator of negative 6 and negative 1, and so my final answer is x plus 2 over 2x minus 7. Finally, my last example, I have f of 4x. So one more time, I'm going to rewrite the function taking out the input variable of x, so that gives me blank plus 5 divided by or over 2 times blank minus 1. In its place this time, I'm going to write the 4x and simplify. So from here, 4x plus 5, there's nothing I can do to simplify that expression, so the final numerator is just 4x plus 5. In the denominator, however, I can multiply the 2 times the 4x, so I get 8x minus 1. And so that is your final answer for f of 4x. All right, guys, good luck.